Hi, welcome to Tammy the Tutor. We are in CC2 lesson 1.2.8. Number 137. Rewrite each fraction in at least two different ways. Okay, we have 6/9, so we can either reduce it or we can make it bigger. Probably, let's just do both because I want it in two different ways. So if we were going to reduce it, think of a number that can be divided into both of these numbers. So I'm thinking a 3. So if we divided the top and the bottom by 3, that would be 2/3. So let's go back to 6/9. What if we doubled both of those numbers? That would be 12/18. Okay. So we've got 11/12. So 11/12 cannot be reduced, so that's not an option. So we're just going to make it bigger in a couple of different ways. How about we double it? Is one way. Another way is multiply the top and the bottom by 10. Okay, easy enough. 3/8 cannot be reduced, so I'm going to double them. 8. Okay. And then I'm going to multiply the top and the bottom by 3. Okay, 10/7. How about multiply the top and bottom by 10, multiply the top and bottom by 2. Okay, I didn't get very creative with that, but you guys get the point. As long as what you're doing to the top, you're doing the same thing to the bottom, there are a million different options. Number 138. Jonathan measured 2 cups of flour into a bowl on the counter. Then he spilled part of it, and now there's only 3/8 cup left. How much did he spill? Okay, he started off with 2 whole cups. He spilled some of it. We don't know what. And then he was only left with 3/8 of a cup. So the main part of this is if I subtracted a piece of 2 and got 3/8, doesn't it make sense that if I subtract 3/8 from 2, I'll get whatever is left over here? So really, we're subtracting 3/8 from a whole number, which is a 2. Okay, so if you are confused of how to subtract a fraction from a whole number, just think about this. 2 can be made into a fraction by putting it over a 1. Let me make it a little more even now. Okay, well, we know we have to have a common denominator. So I need to turn this 1 into an 8, because if I had 8 for both denominators, then I would be good to go. So I'm going to kind of use my giant 1, and I'm working a little backwards than I normally do because I only have room on the left-hand side. But 1 times what is 8? Okay, and then 2 times 8 would be 16. So instead of having 2 minus 3/8, I have 16/8 minus 3/8. And I just want to make a point to show you something. What is 16/8 really? If this fraction bar means divided by, then what is 16 divided by 8? It's 2. So 16/8 is exactly the same number as 2, but I've put it in a fraction form that I can now use to subtract. Okay, so 16/8 minus 3/8 equals 13/8. Let's turn this back into a mixed number. 8 goes into 13 one whole time, and out of 8, I've got 5 left over. 139. Maggie is making muffins with a recipe that yields 18 muffins. There are 12 people in Maggie's book club. If the muffins are divided evenly among each person, how much will each person get? Explain your thinking. Okay, so think about, this is going to be a division problem. Think about what is being divided. Are the muffins being divided, or are the people being divided? Okay, the muffins are. The muffins are being divided among the people. So think about when you write a fraction, what number goes on top? It's the one that's being divided, right? So whatever's being divided always goes on top. So 18 muffins are being divided among 12 people. So that means 12 divides into 18 one time, and out of 12, 18 minus 12 is 6, and that reduces down to 1/2. So every person gets 1.5 muffins. Okay, B, if Maggie wanted to divide the muffins evenly between the 36 students in her class, how much muffin would each person get? Again, what's being divided goes on top, so it's still just 18 muffins, but it's being divided now by 36 people. So 18 is half of 36, so that reduces down to 1/2. So each person only gets 1/2 of a muffin. Okay. 140. If the probability of getting a particular result in an experiment is 75.3%, what's the probability of not getting that result? Okay, so probability, we're looking for something to add up to 100, right? Because if it's 75.3 not happening, we need to find whatever else we could add to 75.3 that would equal 100, because that would be the part that is happening. Those two numbers need to add up to 100%. So of all of these things, we don't want it to be this one because then it would be more than 100%. That doesn't make sense. We don't want this one because it would be a negative number. That certainly doesn't make sense. We're not dividing. It's this one right here. You take your 100 and you subtract your 75.3. Okay. If it's 75.3% not happening, then it's 23.7% that it is, because that's what's left over. Okay. 141. Okay, when you see problems like this with that little check mark, that's called a checkpoint. All that means is by now they think that you should know how to do this kind of problem very well. You should have it mastered. That doesn't mean you won't make mistakes, but by now you should really just know how to do this. So they're kind of giving you that, it's like you need to do a checkpoint on yourself. If you're like, oh, because this is area and perimeter, like I'm good to go, I can totally do area and perimeter of shapes, then you're on the right track. If you're feeling like, uh-oh, I still can never remember what to do with each shape, then that's something that you probably should just go work on. Look it up in the book, ask your teacher, you can Google it on the internet, watch my videos, whatever. But by now, you should be pretty proficient in finding area and perimeter of these basic shapes. Okay, so let's go ahead and do perimeter of all of them first, because perimeter is easier. Remember, perimeter is just finding the outside perimeter, the add up all the sides, outside measurement. So all you need to do is double the 12, it's 24, double the 8, it's 16, and then add them up and it's 40, and that is centimeters. Okay, let's do B. We've got 9.05 plus 11 is 20.05, plus a 5 is 25 and 5/100. Okay, C. 10 and 10 is 20, 16 and 16 is 32, 32 and 20 is 52 centimeters. Okay, we've got 21 and 24. That's 45. 45 and 25 is 70. Let's see, I'm going to keep track of this right over here. Actually, I'll do it here. 70 and 44 is 67. It's 114 and 67 meters. 6,700th meters. Okay, so now we just need to do area. So area of a rectangle is just base times height. So that's just 12 times 8. And that's 96 centimeters square. Okay. For triangles, it's base times height again, but divide it by 2. So 11 times 4 divide it by 2. So you can say 11 times 4 is 44 divided by 2, and that's 22 inches squared. Okay, parallelogram. Again, it's base times height, just like your rectangle. The base is 16. The height is the dotted up, straight up and down line, which is a 9. 9 times 6 is 54. 9 times 1 is 9 plus 5 is 144 centimeters squared. Okay, trapezoid is just like a triangle. Difference is it has 2 bases, so we're going to add them together before we multiply it times the height and divide it by 2. 44.67 plus the top number is also your base. The height, straight up and down, divided by 2. I'm going to go ahead and say 20 divided by 2 is 10. And now I just need to add this and multiply times 10. So 44.67, add 25. You notice how I am making really sure that I keep my decimals lined up. When you're adding decimals, you have to line up. Okay, so it's 69 and 6/6700 times 10. What happens when you multiply something times 10? You find your decimal and it makes it make one hop to the right. And this was meters. There we go. And that was the last one. You got through chapter 1. So good job, and I'll see you next time for chapter 2.